It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. Alright, welcome back everyone. Up to this point in your database journey, you've essentially been acting as architects. Over the last 5 weeks, you've taken these messy real-world requirements and drafted up your conceptual sketches. You've worked through the iterations, you've built a solid entity relationship diagram, and you've really figured out what data exists and how it all connects together. But now, here in week 06, we hit a massive turning point. It is time to transition from drawing those conceptual sketches to actually writing out the concrete technical blueprints. We are locking in your logical design and getting everything packaged up for Assessment 1. So this explainer is going to cover everything you need to confidently tackle this week's material. Okay, let's dive into this. Here's a question I want you to seriously ask yourselves right now, especially as Assessment 1 is creeping up on us. You've got this beautiful, fully normalized ER diagram sitting right in front of you. You've resolved your many-to-many relationships, your primary keys are sorted, and everything looks perfectly organized. But if you were to just hand that diagram over to a developer today, is it actually enough for them to build a robust functioning database without having to come back and ask you 100 follow-up questions? The short answer, no, absolutely not. I mean, an ER diagram is an incredible visualization tool for sure, but it leaves way too much to interpretation. It's time to put down the drawing tools and start writing the specifications. This is the absolutely crucial shift we make this week. We're moving from high-level visual modeling to rigorous, unambiguous written documentation that completely defines your database's rules and structure down to the absolute smallest detail. So here is our roadmap for the next few minutes. Number 1. From diagrams to specifications. 2. Enforcing database integrity rules. 3. Building the data dictionary. 4. Early physical design considerations. And finally, 5. Packaging your Assessment 1. All right, let's kick things off with Section 1, from diagrams to specifications, moving beyond visual models. When we talk about assessments, I really want you to drill this mantra into your head: artifact versus evidence. Your ERD, let's say you're on version 0.4 right now. That is an artifact. It's the thing you built. But on its own, it doesn't actually prove that the database will behave correctly when it's deployed. Written specifications, rules, and dictionaries, now that is the evidence. Evidence proves your design actually works. It shows the marker that you haven't just, drawn some pretty boxes, but that you fundamentally understand the constraints of the data. You understand the business logic, and you have a concrete plan to maintain data quality in a live environment. So Assessment 1 isn't just about handing in a picture. It's about providing the deep, technical evidence that backs that picture up. Moving right along to Section 2, enforcing database integrity rules, where we look at the database as a gatekeeper. You really have to think of your database like a super strict gatekeeper, kind of like a bouncer at an exclusive club. It absolutely cannot just let any random data walk through the door wearing sneakers. Integrity constraints are basically the strict rules you give that bouncer. Now, for week 06, we aren't writing these in SQL code just yet. We're just defining them clearly in plain English. We want to state exactly what makes a piece of data valid, so that later on, the database can automatically reject anything that doesn't fit the bill. This proactive defense stops bad, corrupt, or incomplete data from ever infecting your system in the first place. Now, when you're writing these down for your assessment, I want you to lean on the rule of 3 to make sure you've covered all your technical bases. First up is entity integrity. This rule says that every single row in a table must be uniquely identifiable. Practically speaking, this means it has to have a primary key, and that key absolutely cannot be left blank or null. Second, we have referential integrity. This protects the relationships between your tables. So if a sales record points to a customer record, that target customer record must actually exist. You can't have ghost references floating around. And third is domain integrity, which defines the valid format or range for a specific column. If you skip this, someone might enter banana as their age, and without a rule, the database will happily accept it, which, as you can imagine, causes massive headaches downstream. Domain integrity ensures an age is a positive integer, or that an email actually contains an @ symbol. And this brilliantly illustrates exactly how your visual work translates directly into these constraints. When you drew a line connecting an author entity to a book entity on your diagram, you weren't just drawing a line. You are implying a referential rule. You are stating that a book must have a valid author ID. When you underline the primary key in your entity box, you are created an entity rule. Every author must have a unique, non-null ID. So your job this week is basically to extract all of those visual implications from your diagram and write them out explicitly as formal rules. Okay, on to Section 3, Building the Data Dictionary, which becomes your single source of truth. Look, without a data dictionary, any developer looking at your ERD is literally just forced to guess. What does a field called status actually mean? Does a 1 mean active, or does an A mean active? Or does it literally spell out the word active? A messy, undefined table relies entirely on guesswork. And trust me, if developers have to guess, they will guess wrong and your database will break. On the flip side, a robust table is backed by a strict data dictionary. It serves as the single undeniable source of truth, translating your visual diagram into unambiguous metadata that anyone can follow to perfectly implement your design. No doubts, no confusion. Now, what's really interesting about this slide is that it walks through a literal simulation of the dictionary you need to build. A solid data dictionary breaks down every single attribute in your entire system. You define the exact column name. You assign a specific conceptual data type, like integer for a whole number, or varchar for a text string. You list the constraints. Is it the primary key? Is it required, getting a not null constraint? Does the value have to be totally unique? And crucially, you write out a clear, plain language business description. You do this so anyone looking at it knows exactly what the data represents in the real world. This whole process guarantees absolute clarity before you ever type a single line of code. Next up, Section 4, Early Physical Design Considerations. We're taking a little peek into the future here. Right off the bat, I want to be super clear with you all. You are not writing SQL queries this week. We are strictly operating at a conceptual level today to lower your cognitive load while you finalize all this logic. However, a truly great database designer doesn't wait until the database is built and stuffed with a million rows to wonder how fast it'll run or how secure it is. You need to think about performance right now. Document your intentions in your specs, and then you'll code it later in week 08. One of the main physical considerations we want you to document conceptually right now is security. Specifically, the principle of least privilege. This is a massive foundational concept in IT security. Basically, it means giving users only the access rights they absolutely need to do their job and nothing more. Think about it. You wouldn't give a cashier the keys to the company vault, right? Same thing here. If an application only needs to read reporting data, you absolutely do not give it permission to update or delete tables. Documenting these intended user roles and permissions now is going to make your physical implementation down the road incredibly straightforward. Let's move to and see how this builds into performance tuning through indexes. An index in a database is exactly like an index at the back of a huge textbook. It drastically speeds up how fast you can find information, taking a search that might take minutes and crushing it down to milliseconds. Now, for your assignment, you don't need to write the actual index creation scripts yet, but you do need to conceptually identify your index candidates. Look at your ERD and ask yourself, which attributes are my users going to search for the most? A customer's email address, a product category? Document those specific attributes as prime candidates for indexing. But keep in mind, you don't just index everything, because indexes take up storage space and can slightly slow down the process of adding new records. It's a balancing act. Finally, Section 5, Packaging your assessment. 1, getting you completely ready for submission. When you walk into your lab sessions this week, you've got a very specific step-by-step workflow to achieve that design sign-off. Step 1, apply the final sign-off checklist to your ERD and normalized relations to catch any of those lingering errors in your cardinality or your keys. Step 2, formally write out your entity, referential, and domain integrity rules. Step 3, produce that comprehensive data dictionary for every single table. And step 4, assemble all of this into your A1 evidence pack, ensuring it's formatted professionally and tells a really clear, cohesive story about your design decisions. So the crucial point is that by the end of week 06, your deliverables should look exactly like what is outlined on this checklist. We are looking for a complete data dictionary, a clearly documented set of integrity rules, and a compiled draft of your Assessment 1 evidence pack. Week 06 isn't about throwing massive theoretical concepts at you, it's about consolidating your hard work, polishing up your logical design, and creating the rigorous technical documentation that proves you are totally ready for implementation. As we wrap up this explainer, I want to leave you with a reflection prompt. Look at the design you've spent weeks building. When the marker opens your submission, what specific evidence will you include to prove beyond a shadow of a doubt that your design is robust, logical, and completely ready to be built? Think about that very carefully as you finalize your data dictionaries and rule sets this week. Good luck with your Assessment 1 packaging, and I will see you in the next one.